Hello to my favorite sixth graders. Tonight we're going to be talking about classifying rational numbers. It's lesson 3.1. If you would go to your table of contents first and write the title at the top of my page on the next line, 3.1, classifying rational numbers. And the page numbers we're going to be working on today are page 11 and 12. So please do that in the table of contents and then set up your 6 boxes on page 11, number the bottom, page 11, and then page 12, and then you can turn this back on. All right, so first we need to define what a rational number is, and I've written the definition down. I want you to copy this in your first box. A rational number is any number that can be written as as a fraction, which as a over b, where a and b are integers and b does not equal 0. So the bottom number cannot be 0. So for example, we have 4 rational numbers here. And we're going to write them as a over b to prove that they're rational numbers. But first, don't forget, I want you to copy down that definition. So please do that and then turn the lesson back on. Okay, so first we're going to turn an improper fraction into, a mixed number into an improper fraction. So we're going to multiply the 3 by 5. And then add the 2, so that 3 times 5 is 15, plus 2 is 17. And so that will be 17 on the top. And the bottom number never changes, ever. So it will be 17/5. Then we have a decimal, and the easiest way to do this is to say it out loud mathematically. So mathematically, we would read that as 6/10. So then I would write it as 6 over 10, 6/10. But we always need to make the number in simplest form. And what number goes into both of those? It would be 2. So 2 goes into 6 3 times, and 2 goes into 10 5 times. So the answer is 3/5. So that is written as a over b, in a over b form. Okay, so whenever you have a whole number like this, it's not a decimal or a mixed number, you just have to put it over 1. So this will be 34 over 1. Okay, and our last one is the same thing except it's a negative. So we have negative 7 over 1. Okay, so if you'd finish putting all this in box 1, and then we can move on to box 2. Okay, in box 2, we're going to draw a Venn diagram, and we're going to use that to classify the rational numbers. You're going to need to know how to draw this Venn diagram by memory, because you're going to want to use this when whenever you're asked to classify numbers. Okay, so a few things. You need to draw 3 circles inside each other. Okay, and the largest circle, which is all rational numbers, and those are the numbers that we talked about. Any number that can be written as a over b. Okay, so rational numbers include all numbers. You find positive numbers, you find negative numbers, and you find fractions and decimals. This outside portion is the only place where you will find fractions and decimals. The only place. Okay? You might find a positive and negative number, but it's the only place you will find fractions and decimals. Okay, so that's important to know. So please write those down in red or another color, whatever color you choose. Now inside that outer circle, we have integers. And integers are whole numbers, such as 4 or 5, and they can be positive or negative numbers, okay? So it could be a +4 or a -4, and that would fit right in here. So positive and negative whole numbers go in here, okay, in this second circle, all right? And then in the very center, you have whole numbers, but it is only whole positive numbers. You can't have anything that's negative in the very, very center, okay? So that would be everything, all the whole numbers to the right of 0, okay? So this is a lot of information, and I really want you to copy everything down just like I have on the chart, okay? It says down here, it says integers include all whole numbers. Okay, so as a Venn diagram, you'll notice that the whole number circle is inside of integers and inside the rational number circle. Okay, so everything that is in this circle right here, everything that's in here is also an integer and also a rational number. Okay, and I'm gonna show you that in the next box. So in this box, I really just want you to copy everything down, and then I will give you some examples, and we will it'll become more clear. Also, the rational number that I have written up here, rational numbers include integers and whole numbers. So whole number, like the number 4, a regular 4, +4, is going to be in here. Okay, it will be a whole number, it will also be an integer, and it will be a rational number because it's sitting inside of all 3 of those. Okay, so please just copy down everything that was here. Let me erase everything that was not here. And I just want you to copy down the Venn diagram as it is, and then we're going to add some numbers on the next one, okay? And it would help you if you wrote in different colors too, just like I have. Okay, so let's have some samples now. So make sure you're looking at the Venn diagram that you made over in box 2 when we're placing these numbers. Okay, so I'd like to place the following numbers. Let me choose a color here. 0.35 or 35 hundredths, 3/4, 75, and -3. Okay, so we're going to place those. So let's start with the first one, 35 hundredths. Okay, so look back in box 2 and think out loud to yourself, which part of the Venn diagram do you think it goes in? Okay, it is a decimal, and the only place that decimals can go is in this outer section. So 35 hundredths is going to go here in the rational circle. So it is only a rational number. That's the only circle that it is included in. Okay, then we have the next one, 3/4 or 3/4. Look back in box 2. There's only one spot that can hold the fractions, and that is also rational numbers. So 3/4 goes in this outside circle. It is only a rational number. It's not included in the center 2 circles. Okay, then we have 75. Now 75 is a positive number, so it could go in integers and it could go in whole numbers. But it's because it's a whole number, it has to sit in here. But it's also included inside the integers, and it's included in a rational number. So positive 75 is a whole number, an integer, and a rational number. Do you see how how it's included in all those circles? Because they're all around it. Okay. The next one is -3. Now, -3 cannot go in the whole number circle because it's not positive. The only things that sit in the center are positive whole numbers. So we're going to put that right here in integers, right there. And it's not going to sit in the outside because it's not a decimal or a fraction, okay? But when we categorize this, because the integer circle is inside the rational number circle, it's an integer and it's a rational number because it's sitting inside the big circle, okay? All right, so we're going to do some more samples on the next square. So let's move to square 4. Okay, we're going to classify and these numbers down here at the bottom. And the best way when you're classifying is to draw, like I said, to draw the Venn diagram and put the numbers where you know they go, and then you can figure out which section they are, how to classify them. So 14.1, okay, so this is a decimal, so the only place that decimals can go is in the outside, is in rational numbers. So we're going to put this right up here, 14.1. And then we have 106. Well, 106 is a positive number, and so a whole number. It's not a fraction, it's not a decimal, so that's going to go right in the center here. Okay, then we have a -5. Well, it's a whole number, but it's an integer actually. It's not a fraction, it's not a decimal, but it's negative, so it can't go in the very center because no negatives are in the center, so it's going to go right here in integers. Okay, the next one is 5/7. Remember, where's the only place that fractions can go? Out here on the outside circle, 5/7. Okay, -0.4. Now some people get confused. As soon as I put a negative on it, they think it goes in the integers. But no, it is a decimal. So the only place decimals can go is in the outer circle. Okay, 0.4, -0.4 goes in the outer circle. And we have 5 and 10/11. Okay, even though it's not written as A over B, it could be written as A over B. We could write it as, it would be 65/11. But we're just going to write it like that. And what's the only place that fractions can go? The outer circle. So it's going to go here. 5 and 10/11. Okay, so now when we're classifying these, and they ask us what are these numbers, they want us to classify them. And 5 and 10/11 is just a rational number. That's it. It doesn't fall into any of the other circles. Same with -4/10. That's just irrational. 14.1, just rational, and 5/7 is just rational. Okay. Now, -5, it fits inside the integers circle and inside the rational number circle. So it's going to be both an integer and a rational number. Okay, and then are you ready for this? 106 fits in all 3 circles. So it is a whole number, an integer, and a rational number. All 3 of those. Okay, so anything in this center circle is going to be a whole number, an integer, and a rational number when you're classifying and listing the names for it. Okay? All right, we're going to do some more examples. Let's move on to box 5. Okay, in box 5, I want you to have a little bit of practice in writing these numbers as in the A over B form. Okay? So, we're going to read the first one mathematically. And mathematically, if we read that, it's 7/10. So then I would just write 7/10. Okay. -29. Remember, if it's not in a fraction already, we just put it over 1. -29 over 1. Okay. Now we have a mixed number that we need to turn into an improper fraction. So we multiply 3 times 8. Is 24 plus 1 is 25, and so we have 25 over 3. Okay, remember bottom number doesn't change when we do that. Okay, we have another mixed number that we need to change to an improper fraction. So we multiply 1 times 8 plus 3, which is 11. Bottom number doesn't change. 11/8. Okay. The next one, if we were to read it mathematically, we would read 75 hundredths. So let's write that out. 75 hundredths, but that is not simplest form. And it's a good idea to always put them in simplest form. So what is the greatest number that goes into both of those? Well, it would be 25, the greatest common factor. And so 25 goes into 75 3 times, and it goes into 100 4 times. Okay, so 3/4. Now we have 12, and it's a whole number, so we just put it over 1, 12 over 1. And the same goes with that 9. We'd put a negative in front of it, and it is negative 9 over 1. Okay. Okay, we're in our last square and examples. Now, if you want, you can try placing all the numbers at the bottom in the in what circle you think they go in, and then check after I've done it, or you can just watch. Okay, we will definitely do more of these examples tomorrow in class. Okay, so negative 15. So as soon as I see it's negative and it's not a fraction or decimal, I know it's going to go here. Okay, because no negative numbers can go in the center. Okay, 5 and 10 elevenths. Well, that's a fraction, so that's automatically going to go out here in the outside. So that's a rational number. 23/6. Again, the only place that fractions go. 23 over 6. Negative 3/10. Well, that's a decimal. So it will go out here. And we have 6 2/3, negative 6 2/3. Okay, now remember, just because it's negative doesn't mean it goes into where the integers is. It's a fraction, so you cannot, the only place you can put that is out here on the outside, 6 2/3. Now I didn't give you an example of a whole number, so let's do that. Let me just write, well, I can write any number, 47. Okay, it's not negative, it's a positive, and it's a whole number, so it's going to go right here in the center. Okay, and so if I were asking you to classify these, and I said, would you classify 47? You would say, well, it is sitting inside the whole circle, so it is a whole number and an integer and a rational number. It is surrounded by all three of those circles. And if I ask you to classify negative 15, you would say, well, it's outside here, so it's in the integer circle, and it's also included in the rational numbers circle, so it is both of those. It's not in the whole number, so we can't call it a whole number. Now, any of the fractions or decimals on the outside, we only call them rational numbers. We don't call them integers, we don't call them whole numbers. They're only in the rational number circle. Okay, all right. Well, I know that's a lot to copy down in your squares, but I think if you have all this information, it will make it so much easier tomorrow when we do the examples in class. All right, have a good evening.